Hello again, everybody. I thought I'd run through a couple examples actually using the fundamental theorem. We'll use the first part here. We've got some function, you know, defined in general from a to x of f of t dt. So this is, f of t dt. So this is essentially, g of x is the area from a to some variable x of this other function f. Okay, if we take the derivative of that, in general, as a function, we will get the original function under the integral sign. The integrand is what they call that. Okay, so the derivative of your integral is your integrand. Your integrand is what's inside. So it seems pretty simple. That's fundamental theorem part one. Seems logical. Again, I think one of the things we talked about in class was, if you've got a car traveling at a particular speed, let's say you're going, this is your velocity function at, let's go 88 miles an hour. Okay. So you've got a velocity of, this is v, this is t, and let's go for, I don't know, 3 hours. Okay, so you got a velocity of 88 miles per hour for 3 hours. Let's assume your flux capacitor is working just fine. You've got enough plutonium to get you where you need to go. And my question would be, how far did you travel if you're going 88 miles per hour for 3 hours? Well, you guys would figure that out. Just be 88 times 3, 200 and, I don't know, 64 miles, whatever it is. But 88 times 3 is the area under that curve. Okay, yes, it's a straight line, but you get the idea. The area under this curve represents the amount of, distance that has been traveled. Well, if this is velocity, and you're telling me I'm getting distance by finding the area, well, isn't distance the antiderivative of velocity? Right, remember our position function versus velocity versus acceleration, right? We've got, acceleration, which is the derivative of velocity, which is the second derivative of position, right? So I wanted to also put this one. That probably makes more sense too, right? Velocity is the derivative of position. The second derivative of position is the first derivative of velocity, which is acceleration. So let's go backwards. If you want the position, right, this is s prime now. Well, if you take the antiderivative or the integral of velocity, won't that give you the antiderivative or integral of position prime, which is just position? Okay, the notation's not so great there, but it's the same idea. So the derivative of your integral is your integrand. This is what I want you to kind of see there. Okay? Now, let's look at an example of something that you'll actually, be able to, you can apply this. So example number one, let's start with, g of x is the integral from, let's say, just 0 to x for the square root of 1 plus t squared dt. And I want g prime. Well, g prime is just going to be f of x, right? F of x. So f of x is going to be the square root of 1 plus x squared. And that's it. That's really it. The only time these really get tricky is when they do something like this to you. A little bit of shenanigans going on over here. What about if it was 0 to 2x of 1 plus t squared dt? Well, the beginning of it basically is the same thing. You're still going to do the derivative, which is going to give you the integrand, square root of 1 plus, this time it's not just x, it's 2x. So it's 2x squared, and then there's a little bit of shenanigans. Unfortunately, our fundamental theorem only goes to x. So essentially, you have a thing here that's not just x, and you're trying to take the derivative. Well, whenever we had to do that before, we always had a chain rule kicker. So in this case, yeah, you still put in your x, or in this case, 2x. But then you got to multiply by the derivative of what's inside, which the inside is the thing here is the 2x. Derivative of 2x is 2. And that would be your g prime. Okay, that's a very basic example of fundamental theorem part 1, but that'll probably be able to get you through some of those homework problems from page 348. If you need any help with that part of it, just let me know. I'm about to do another video for using the other fundamental theorem portion where we actually evaluate to get numbers. Okay? Let me know if you have any questions.